Hello worldly crazy people out there, my name is Michael, I like wizards and dragons and making games. Welcome back to 3D Games in GameMaker. Today we are going to finish off dealing with Frustum Culling. Last time we set up the data structures that would be needed to represent the camera's frustrum, in other words the area that the camera can see in front of it. And today we are going to be checking the camera's frustrum against the collision hierarchy to quickly and somewhat efficiently figure out which objects are actually in view of the camera and which objects are actually worth rendering. So, obligatory prerequisites, you're going to want to know what happened in the previous video in the series in order to construct the camera frustrum. This whole thing is going to be built on top of the 3D collision system that I've been working on for 2 years. So, Frustum Culling. This is what the 3D scene looks like now. This is what it's going to look like by the end of the video. Just to reiterate one of the warnings last time, GameMaker language is a little bit on the slow side, and while not drawing stuff that you don't have to draw is always nice, it's not necessarily going to be the silver bullet for solving performance issues in your 3D video games. I'll try to sufficiently cover that at the end. But first, let's start checking shapes against frustrums. So I'm not going to go and check every single shape in this project against the camera frustrum, because honestly that'll take about 3 hours and I don't really want to do that. And in most cases, you're only really going to care about spheres and frustrums and AABBs and frustrums, maybe AABBs and frustrums anyway. Let's see, some housekeeping. I meant to do this last time and then forgot, but if I were to go into the call camera frustrum code over here, some of the other data structures, matrices, vectors have an asArray method, which will simply return their members in a linear array so that you can loop over them. And I'm going to do the same thing for a camera frustrum. Order here doesn't matter. I just want these in an array so that I can loop over them later, because we're going to be doing a fair bit of looping over these things later. Secondly, and I guess I'll just dump this at the bottom of this frustrum code file here. Generally speaking, there are 3 possible results that you can get when you check to see if a shape is intersecting a camera frustrum. It can be completely outside it, it can be completely inside it, and it can be partially intersecting it, partially intersecting one of the faces, one of the planes that makes it up. And as much as I'd like to just define a bunch of check frustrum methods and have them return simple true-false values, it, in my case, is going to be quite a bit simpler. Well, it's not going to be simpler, but it's going to be, it's going to produce a somewhat better result if I differentiate between those 3 situations. So I'm going to do that, define an enum. This is going to be enum, what do we want to call this? I guess I should probably prefix my enum types with like E, right? E frustrum results, that sounds good. We can say this is going to be outside intersecting and inside. So most, if not all, of the frustrum checking code is going to return one of the members of this enum. So either outside intersecting or inside. Okay. This will be some project maintenance. Alright, let's start with points. This is going to be easy. So if I say, let's say static check frustrum is going to be a method that's going to take a frustrum as an input. If I were to get the array of planes comprising that frustrum, so I can say planes is going to be frustrum.get planes, and if I were to loop over this array of planes, and you could use whatever looping structure, control flow structure you want here. You could use a for loop, a repeat loop, I don't care. If we were to look at each point and figure out if it is in front of, if the point in question is behind any of the planes, so if it's either behind the far clipping plane, it will be farther away than the camera can see, and it will be outside the frustrum. If it is behind the near clipping plane, it will be either between the near clipping plane and the camera and therefore invisible, or behind the camera and therefore invisible. By the way, I don't think I said this, but each of the 6 planes in a frustrum in this case is going to have its normal pointing inwards into the frustrum, so into where the camera can see. I feel like most people assumed that that is how the planes are arranged and like oriented in space, but in case you are wondering. Anyway, back to points. So we planes have a fancy method called the plane equation, which we've used in the past a few times to figure out if a point is in front of or behind us or perpendicular to us. It's basically the dot product for points and planes. But I'm going to do something a little bit different here, and I'm going to, instead of using the plane equation, which is essentially going to be the plane, the plane's normal dot producted against the position minus the plane's distance, I'm going to instead add the plane's distance, and that's going to, that'll tell us how far in front of or behind the point is from the plane. Let's call that the distance. If the distance is less than 0, then the point is going to be behind the plane, and as stated, if the point in question is behind any of the planes comprising the frustum, then it will be invisible to the camera, it will be outside the frustum. We can return frustum results.outside. Otherwise, we can return frustum results.inside. So this is going to be what our, what did I call this earlier? Proof by exhaustion, the Sherlock Holmes proof. If you can't find a way to prove that the point is outside the frustum, it must be inside. In this case, since points are infinitesimally tiny, you know, coordinates, I won't be differentiating points that are quote-unquote intersecting the plane, points that are basically lying on one of the planes versus points that are actually inside. We're not actually going to be using points and frustums for anything in this project, but I thought this would be a good starting point to talk about some of the bigger shapes that actually have volume, because those we will actually be using. At least I'll be directly using AABBs. I won't directly be using spheres, but we're going to talk about those two for similar reasons. And if I were to move over to the call spheres code, let's go down to the bottom. Let's actually just copy and paste the check frustum code, because as I said, it's going to be very similar. So spheres versus frustums. We're going to take the planes in the frustum as an array. We are going to loop over that array, and we are going to check to see how far in front of or behind the sphere's central position is relative to each plane. However, since spheres actually have volume, or at least since spheres actually have surface area anyway, then in addition to the sphere being completely inside or completely outside the frustum, it is also possible for the sphere to be intersecting a frustum. If the distance between the sphere and one of the planes is less than the sphere's radius, then it's going to be intersecting that plane, and therefore will be partially inside and partially outside the frustum. I believe we did something similar to that when it came to checking spheres versus planes up here. Sphere versus plane, you don't care if it's in front of or behind it or not, as much as if the distance to the plane is less than the sphere's radius. So in this case, if the distance is less than 0, we're going to want to amend this to if the distance is less than the negative sphere's radius. Because after all, spheres are big points. Every time I think I've made that joke for the last time, I make it again. You might also be tempted to take this a step farther, in this case, to deal with the, like, intersection cases by saying if perhaps the absolute value of the distance is less than self.radius, and that'll account for if the distance from the sphere to the plane is less than the radius in the positive or the negative direction. Then you might consider returning frustum results.intersecting. But this actually turns out that it won't really produce good results, because as we loop over the planes array, it is possible for the sphere to intersect some planes and be behind others, and for the purposes of figuring out if a sphere is inside the frustum or not, knowing if it is outside completely is more important than knowing if it intersects another plane somewhere. So what I'll do, and this feels like kind of gross code, but it seems to be the best solution. I'm going to keep a second variable that's going to be is intersecting anything. We can initialize that to false, and we can say if the absolute value of the distance is less than self.radius, instead of it being outside and early exiting like this, we can simply set is intersecting anything to true. And at the end, if this is true, I'm going to use a little conditional operator here. So if any plane intersections were found and the sphere is partially inside the frustum, we can return frustum results dot intersecting. And if no plane is being intersected, then it must be completely inside the frustum, and we can return frustum results dot inside. Okay, a little more complicated than checking points versus frustums. You can carry this over 2 points if you really care that much about a point that is lying completely flush against one of the planes. But I can't say I do. That's going to be sphere versus frustum. So AABB versus frustum is where things start to get a little more fun. So I'm going to copy and paste the sphere code again, but we're going to have to make a few more changes here, I think. So you might be thinking of a few different ways that we can check if an AABB is inside a frustum or not. You might think the same way that we take the 6 planes of a frustum, loop over them, and check each of them in turn. You might think about getting the 8 vertices of an AABB, or an AABB. Pretty much anything I say here will work for AABs or AABs interchangeably. And you might think about checking each of the 6 planes of a frustum against each of the 8 corner vertices of an AABB or an AABB. And if all of the 8 corner vertices are behind any of the planes, then you know that the AABB is outside the frustum. If all of the 8 points are in front of all 6 of the planes, then you know that it's completely contained. And if different points are on different sides of some planes and others, then there's going to be an intersection. So that's going to be the middle case, right? But that's going to be a lot of math. That's going to be 6 planes times 8 corner vertices is going to be 48 individual checks, worst and also average case, and we really don't want to do 48 individual checks for every single axis-aligned bounding box that we are doing. That's going to be a lot, and what I've decided to do instead is I've decided to go with a imprecise but often good enough solution, and that imprecise but often good enough solution is going to be basically treating the AABB like a sphere. And the position of that sphere is going to be at the center of the box, and the radius of that sphere is going to be the magnitude of this half extents vector over there. So that's going to be the radius between the center of the shape and one of the corners. And since this is like a regular geometric shape, it'll be the same distance to all the corners. And we'll have a sphere that circumscribes our box. And instead of having to deal with a lot of like corners and surface vectors and that kind of thing, we're simply going to wave our hands and say that this is going to be a good enough approximation of whether or not an AABB is within a frustum, because again, we don't want to do a lot of work in the name of saving ourselves a lot of work. So it's going to take the same general shape. We're going to loop over all the planes. We're going to immediately exit if we can figure out that the shape is completely behind any of the planes like this. And if there's an intersection found, we'll save that result and then return either inside or intersecting based on the result at the end. The distance is going to be calculated. Well, it's going to be calculated, but we'll get to there in a minute. And the radius, I said a minute ago that it would be self.half extents dot. Let's call this R. Let's say the position might be. Let's call this self.position. And if you wanted to, you could construct a new call sphere with the position and the radius, and you could like check that against the frustum. But that sounds like quite a lot of additional processing overhead when we really only need like this line of code here. In fact, I don't even need to like save the position separately. Planes index I normal dot product against self dot position plus planes index I dot distance. The only thing I really need to change here is going to be if the distance is less than the negative R, because we don't have a self dot radius with the shape, then return outside. If the absolute value of the distance is less than positive R, then we are intersecting. and then we can return that result. Okay. Much better than checking 8 individual points against each of the planes every time. Sounds like a massive pain in the neck, and I don't want to do it. And again, you could copy and paste this into the call AABB code. I think the only thing you would have to change would be to rename half extents to size. Generally speaking, checking if a sphere is colliding with another shape is really easy, and that's actually going to be a topic that I'm going to be probably getting quite a bit into in future videos when I talk about optimizing the system. Because if you can do things such as check if a sphere is intersecting like a triangle, instead of checking if 2 triangles are intersecting each other, if the circumscribed spheres are not in contact with one another, then you know it's impossible for the triangles to be in contact with one another, and you can save quite a lot of work in that department. But that's a subject for another day. So next, let's hop on over back to the world, and we're actually going to see this in action first, because I know I'm going to forget if I do this later, but I'm going to comment out the spatial hash collision world hierarchy, and instead bring back the original. I believe this is going to be an octree. So this is only going to work with quad trees and octrees because they are recursive data structures, and you can use that recursive property to quickly prune off branches of the tree that you know are nowhere near the camera. And spatial hashes do not have that luxury. Spatial hashes, you could probably make them work with Frustum Culling, but it's going to be a lot more pain. Generally not a pleasant ordeal, so I think I'll be sticking with the tree structures for now.
Hey.
Is there anything else that I wanted to change before I moved on? I don't think so. Some of you may have noticed earlier that I was doing some kind of like back of the envelope, very hand-wavy Frustum Culling with regards to the trees, just basically taking the dot product of the camera's look direction and the dot product of the direction from the camera to the to each tree, and if it was like behind the camera or otherwise way out to the side, then the tree just wouldn't be drawn. And that's pretty good. It's pretty fast. Definitely will save you a lot on speed, but it can produce some erroneous results, especially with objects that are really close to the camera or really big. So we're going to be pretending that that's not on the table for now. And as of right now, the camera frustum, it was being drawn with the Z-writing, Z-testing turned off, and that was causing the lines of the camera frustum to be drawn over everything else in the world, even when they should be like passing through things. I did that earlier so that it was a little bit easier to see where it was, but I think now we're actually going to want to like see what this camera frustum looks like in space. We're not going to want to see the lines being drawn on top of other things if we want to see like stuff outside of those lines being culled properly. All right. By the way, before I forget, pay attention to the FPS_real meter and some of the other debug stats. Right now, we are rendering all 3,000 trees in the scene. They're actually all being rendered twice, once in the main camera and once in the overhead camera down here. That is offering us about 90-100 FPS_real and about 6,000 vertex batches. Vertex batches aren't like absolutely crippling when it comes to performance, and it's not by any means the end of the world if you have a lot of them, the way that some GameMaker users might imply. But if we can get away with doing a few less of those, that would be nice. The camera's far clipping plane is extremely close right now, and that is because I wanted it to like be all in view of this like sub camera down here at the bottom and not be just flying off the screen. That might make it a little bit hard to really appreciate objects being culled out when we finish implementing that, so I will increase that a little bit in due time just so that it's more to look at. Also, when it comes to the Yo-Yo compiler, by the way, in case you want to compare and contrast the before and after or whatever, we're getting slightly better performance here in the Yo-Yo compiler. It's not dramatically improved. It's the same number of trees being drawn, the same number of vertex batches. Instead of 90 to 100 FPS_real, we're getting about 120 to 130 FPS_real. Small spoiler, the benefit of this will be a little bit more when it comes to the Yo-Yo compiler, because we are going to be doing more in math in GML when we do this. And that is something that, like compared to just drawing everything, this is mostly outside the control of the GML that you write. This is mostly handled by, you know, the rest of your computer. But figuring out all this stuff is something that's going to be a little bit more friendly towards the OYO compiler. So I'm going to move where the frustrum is defined from the bottom of this code file to the top, the bottom of this function to the top. And down here, where we are drawing all the things, I'm going to... The way that I'm going to access the called objects is going to be that I'm going to give the collision world, so that's going to be self.collisionWorld. I'm going to give this a method, and it's going to be called something like getObjects in frustrum. And it can take a frustrum as a parameter, and you could have this return one of a few things. You could have it return an array of arrays, or an array of the octree nodes. You could have it return a linear array of all of the objects just as they are. I think I'm going to do that in this example. I will mention the changes that you'll need to make if you want to do the former, if you want to just have it return the array of either chunks or just arrays of contents. I just think personally I would rather call this method on the collision world and just get a singular array of objects without having to like have arrays or anything like that. So let us go over to the call world code, and in the call world function, in the call world constructor, let's define ourselves a new method, static get objects in frustrum. That's going to take a frustrum as an input parameter. So for the most part, this is going to be a lot like the check array method of call world, and all we're really going to do is pass off the task at hand to the acceleration structure, be that a octree or a quadtree. And also like check array, we're going to create ourselves an output array, and we're going to pass that into the get objects in frustrum method in the octree and the quadtree as well. Very similar to the hit info struct that was created in check array. And that is because I would love to be able to just like have each of these functions like return a list of objects that are contained within the frustrum intersections. But passing and returning arrays in and out of functions like this in recursive structures, I just find to be like really annoying. So even though this isn't super object oriented to like give methods a results data structure that they just stick the results in, I'm going to be doing that. So let's see, there will be no if. We can say self.accelerator.get objects in frustrum. The frustrum can be that, the output can be that, and when we're done with all that, we can return the output. And now we've just basically passed the work onto the tree structures. So I'm going to go into the octree, and I'm going to go down to the bottom. I'm going to define get objects in frustrum. As established, this is going to need to accept an output for which it will populate with objects if those objects are believed to be inside the frustrum. So as stated, there's basically three kinds of things that can happen when you check a bounding box against a frustrum, or any other shape against a frustrum. It can be completely outside it, it can be completely inside it, or it can be intersecting. So I'm going to figure out which one the bounds of each of these tree nodes are doing. So we can say, I guess I'll call it like status or something. Status is going to be self.bounds.check frustrum. And that's going to return one of the enum values that we set up earlier, remember? If it is completely outside, then that really makes our work easy. So I can say if status equals e frustrum results dot outside, then we don't have to do anything. We can simply return, and we can just not do anything. That's the lazy solution. Personally, I'm a fan. However, if status equals e frustum results dot inside, then the bounds of this node is completely inside the frustrum, and if that happens, we know that every single item in the contents array of this node is going to be, each of those objects is going to be within the camera's view. So we might as well just append the results onto the output array. And thirdly, you know what? If neither of those two cases are true, if we are intersecting, in that case, we're going to have to look a level deeper. So we're going to have to loop over. So for var I equals 0, n is array length. And once again, you could use whatever loop flow control you want here, for loop, repeat loop, array for each, whatever. And we are going to say self.children index I dot get objects in frustrum. Thank you for the autocomplete there, Feather. The frustrum is going to be that, and the output is going to be that. And this node will pass it a day because it has just magically made this the problem of all of its child nodes. Okay, so these two cases are done. I'm gonna have to do a little bit more work with inside. So it's also possible that even if a node is intersecting the frustrum, so even if it's not completely inside the frustrum, there is one situation where you might as well just append every single object to the output array, and that is that if we've hit the bottom of the recursive data structure, so if there are no more subdivisions to check. And yeah, you could, in that case, check every single object individually against the frustrum. That's not a great idea. That's going to be slow. That's what we're trying to avoid having to do. And if I keep wanting to call it a root node, but that's like the other side of the tree. If one of the terminating nodes is intersecting the frustrum, then we might as well just treat it like it's inside. And the way that I'm going to check for that is by saying if status equals frustum results set inside, or self.children equals undefined, because before a node gets split and subdivided further, the children array will just be initialized to undefined like this. And you can check that. You can check if like the recursion depth equals 0, because that'll also because that's how the nodes know that they shouldn't bother subdividing further in the first place. And let's see, it would be super nice if GameMaker gave you a way to append one array to another. You might consider using the array concat function, which is one of the newer additions to the array functionality in GameMaker, but this will, instead of concatenating an array in place, it will return a new array, which isn't really what we want, so that's out. You might consider looping over the value of the contents array and individually array pushing everything from the contents of this node onto the results array, but that is also going to be slow, and we don't want to do that. Instead, I think I'm going to just basically resize the array and copy the contents from my node contents onto the output. Let's see. So this is going to be var, let's call it output length. It's going to be array length of the output var length, thank you. Contents length. We can array resize the output array to the new size of output length, so its original size plus the contents length, so we're going to resize it exactly as big as it needs to be. And we can array copy. The destination can be the output, the destination index can be the old size of the output array, the source can be self.contents, the source index can be 0, the source length can be contents length, so that'll be filling the whole array. At some point after this, I'll probably submit a feature request to GameMaker to have some kind of array concatenation in place function like this, but this will do for now. It's only 4 lines of code. let's see, is there anything else I have to do? You could copy and paste this exactly to the quad tree structure because nothing in here, everything in here is just generalized to a tree size of any, like, dimensionality. There's no, like, hard-coded, like, 8, you know, array subnodes or anything like that hard-coded. I think we can move on. Alright. Before I copy and paste this to quad tree, though, I will just run it just to make sure that it works. And, the last thing to actually use it will be to, instead of iterating over the array of all the things in the game world, we can iterate over only the array of objects that are inside the frustrum. One small caveat here. So instead of this array, this objects array, containing either GameMaker instances or structs representing each of these trees or anything else that you might use in your game to represent like a physical object, this is actually going to be an array of it's in call world at the top, I think, array of call object, and these call objects are basically containers containing, for example, a collision shape, a reference to a GameMaker instance or a tree struct or something else, as well as some other code that's used in collision detecting. And that's great for the collision system because it does serve a few utility purposes, but we don't really care about any of the other things besides the reference to the actual object when it comes to Frustum Culling. So I can safely say tree equals objects index I dot reference, and that's just going to be a reference to whatever instance you bound to the collision shape. So I can run the game now, and if this works on the first try, I'll be amazed. It actually didn't work on the first try, because this is actually like the 4th time I'm recording this video, because different things kept going wrong, and then I decided that Frustum get planes. That should be as array, shouldn't it? That's silly. Yeah, the first 3 times I recorded this video, I either didn't like the way that it went, and thought it was too, like, long and rambly, or, other things went wrong, and I decided it would be easier to just redo than fix. I'm liking this take so far, though, so I hope that... Alright, here we go. Let me collapse this debug overlay over there for a moment. Yeah, I'm liking this take so far, though, so I'm hoping that it works out. So we can see in the overhead view that everything in the main view is fine. At least as far as, like, the extremely short render distance goes. And we can see that everything that is outside the camera frustrum, like, in its entirety, and there's a couple literal edge cases where you can see, like, a couple chunks on the corners of one of the frustrum are, say, partially in bounds and partially out of bounds. But other than that, if you were just looking at the main camera, you would not know that anything outside this view was completely being ignored. And like I said, this is going to look a little bit better if I were to push out the render distance a little more. Let's make this like 800 or so. I think it was 1,000 originally, I can't remember, but 800 sounds good to me. It's already going to be 3 times farther than it is right now. And yes, GameMaker, thank you for opening up the big fat debug overlay. Like that. So this, I think, makes it a little bit easier to see what's going on here. Again, if you were to look at the main camera, you wouldn't know that things behind you were not being drawn. We can see somewhat satisfyingly that only objects that are in chunks that are near or around the inside or around the frustrum are actually being rendered, so that's good. You might notice that the FPS is actually worse than it was when before I started doing this, and that is one of the things that I meant when I alluded to GameMaker language being a little on the slow side and doing a lot of math like this, not really being something that it's happy about doing. If I were to run off outside like the boundaries of the world, you might start to notice it picking up a little bit, because like from here we can prune off things that are not in view of the camera more quickly. I'm actually going to change that back to 250 because I want to compare that against the YYC. and see if we can do better than 120, 130 FPS underscore real with the YYC. When I was testing this, it was a little better, but it wasn't like extreme. It was more like 150 FPS underscore real that we were getting. Yeah, that's going to take a moment to compile. And if I can get like 150 FPS underscore real, I'll call that a victory. Okay, it actually looks like that's approximately what we're doing now. So 150, 160 FPS underscore real, compared to the 120, 130 that we were getting earlier. Again, culling is working correctly. If you were to push this out a little bit, it would look better. Let me switch back to VM because I don't feel like sitting there and waiting for it to recompile every time I run the game. Okay, so some of you may have realized that some of the objects that are returned by the getObjects in Frustum method in Call World might be duplicates of each other. There might be duplicates of some of the objects that are like on the boundary between two chunks, because they will be included in both chunks for collision purposes. And GameMaker has a function called ArrayUnique, which is another one of the fancy array additions, and that will return an array which contains no duplicates. So if there are any duplicates in the array, the subsequent copies will be removed. And I wish I could say that this will improve performance further because it'll remove duplicates, but for whatever reason, GameMaker's ArrayUnique function is slower than it really should be. I've submitted a bug report / feature request for them to like fix that, but as we can see, the number of objects drawn has gone down a little bit from before because duplicates have been removed, but we're not really getting any better performance because ArrayUnique is taking up a little bit more time than it really should be, and that's a bit of a shame. Let's see. I think for now, I'll remove that and just say if GameMaker ever fixes ArrayUnique, we can use that there for a minor performance gain. I will note that I have experimented with ArrayUnique on new runtime, and it does not appear to be as bafflingly slow in the new runtime as it is in current runtime. So at the very least, whenever new runtime comes out in like a year, that'll be dealt with. But hopefully, GameMaker fixes that for current runtime at some point before then. All right. Yeah, let's use the correct method name there. I think I was just like typing what I was saying out loud, which is how I ended up with getPlanes instead of asArray. Oh, before I commit this whole thing, we can also safely move getObjects in Frustum down to the quad tree as well. And while we're on the subject, since quad trees are generally a little bit more efficient than oct trees when it comes to the collision hierarchy, if you're not actually using the verticality, let's see how this performs with a quad tree. I may also want to resize. Yeah. So this is somewhere where the radius of each of the boxes isn't really going to work to my advantage. I may want to resize the collision world on the vertical, because when each of the chunks is very tall like that, and they're not subdivided vertically, their radius is going to be very big, and none of them are actually going to be like detected as being outside the frustrum. So let me try that again. All right, that's considerably better. That's honestly back to the like 110-ish FPS underscore real that we were getting before I started messing with this in the original test. So I've said it ad nauseum in the last two videos, GML is on the slow side, and when it comes to submitting simple 3D models like these on relatively recent computer hardware, figuring out if something is actually in the view frustrum is likely to be more expensive than actually just drawing everything. Situations where that's not the case, if you have a very dense world with a lot, and I mean a lot of visible objects inside it, to the point where maybe they're not necessarily all collision objects, but maybe they're just like, you know, decorative grasses or something like that. And if you have a lot more objects that are going to be culled out by the Frustum Culling, then you're likely to see more performance gains than I did here, because if you have 10 times as many objects in the world, get objects in Frustum is likely to not take 10 times as long. It might take a little bit longer because it does have more objects to copy into the output array, but if it's still checking the same sized quad tree or rock tree, then it should scale better, and you should be able to get more mileage out of eliminating more objects from having to be drawn or processed. If you have objects that are larger than just a few hundred vertices, these are very simple, or are they? These are very simple 3D models. If they look familiar, that is because they are one of good old Kenny's nature kit trees, and they tend to show up a lot in a lot of like demos and indie games and that sort of thing. But if you have 3D objects with thousands and thousands of vertices, and maybe you're running a forward renderer with a bunch of complicated shaders that are a little heavier to process on the GPU, or maybe you're trying to target a device such as a Raspberry Pi, which, believe it or not, the Raspberry Pi is a decent CPU for what it is, but it has a much weaker GPU. And if you're trying to target a device like that, then a trade-off of doing a little bit more work in GML on the CPU versus just drawing everything and doing it on the GPU might be a trade-off that is a little bit more appealing to you. And then, of course, there's the matter of if you're using the Yo-Yo compiler. And as we discussed, the Yo-Yo compiler is quite a bit better about efficiently doing all these math calculations. And if your game is solely running on the Yo-Yo compiler instead of the GameMaker virtual machine, then the break-even point for you will likely be a lot more accessible. Another thing I could do to make this a little friendlier is to decrease the number of subdivisions, and that is going to increase the chunk size and increase the number of like objects that I'm collision checking against in the like when we're actually doing our collision checking. But it'll also, by increasing the chunk size, mean that the Frustum Culling has to do a lot less work. And it seems that we, at least at first, had a bit of a performance boost over there as well. Anyway, enough of that. So I wish I could say that this brings us to the end of 3D collisions in GameMaker, but I think all that talk about performance and optimization is a nice transition to the matter of optimization in the system as a whole. So over the last, I don't even want to know how many videos at this point, but over the course of the series, I have mentioned on and off about different optimizations that you can do and how I was occasionally writing less than optimal code for the sake of readability. I think spending some time on just doing nothing but talking about optimizing the system would be justified. So there are a couple of easy techniques. I've mentioned a couple of times using enclosing spheres as a inexpensive early test to see if two objects are even remotely close to intersecting each other. I think that's going to be the easiest change that you can make to the system that will have the most effect. There are actually quite a number of other things that I've written down that can be done to speed this along a little bit. Anyway, the reason I bring this up now is that, one, I know you all are nerds who like to hear about that, and two, if you have any particular things that you want to see when it comes to optimization, let me know. I have a list. You'll see the list of things that I'm probably going to at least mention on screen right now. But if there's anything that you think might be worth talking about that isn't on this list, then lay it on me in the comments. Until next time, my name is Michael. I like wizards and dragons and making games. I hope you all find this useful. If you want the code for this, look for the GitHub repository down in the video description. Before this video goes up, I will merge these changes back into the regular 3D collisions repository, by the way. I try to post about 2 game dev videos a week, one tutorial like this, and one Let's Make a Game. I have a Patreon, so if you want to contribute to the channel, links to that can be found in all the usual places. I would definitely appreciate it if you did. These videos do take quite a lot of time to make. I will see you all later. Special thanks to Zenjamin, Vitro V, Squarecrow, Syndra Larson, Manta Ray, GameMaker, Edward Holt, DJ Gibbles, and Army Armbuster for supporting these videos. If you want to contribute to the channel, head on over to the Patreon page down in the video description to join the fun.